Alrighty. Hello, everybody, and welcome to the third week and I believe fifth session of my character materials and rendering class workshop sort of thingamajig. Um, if you saw the curriculum that I posted online a while ago, I am going to be switching a couple of things around for tonight. Instead of talking about UVs and texturing in that way, I'm switching over to talking about shaders. And then on Thursday, the next session, I'm going to be talking more about UVs, the 0 to 1 space, that type of thing. I just figured that this would be a bit of a better way to proceed given some of the things I'm going to be talking about and how some things are going to be based on things that most people, if they've been doing 3D for any amount of time, they'll be pretty familiar with them anyway. So anyway, we're going to be talking about character shaders tonight. The different types of shaders that you'll run into, how you can use very basic shaders to do some pretty fun things, along with more advanced or specialized shaders, such as skin, hair, refraction, and cloth shaders. I'm going to talk a little bit more about energy conservation, just briefly, for skin shading, because I know that that's kind of a sticking point. It's something that people get confused about a lot. I'm also going to be talking about the importance of scale, whether it's model scale or scene scale. I'm going to be talking about special case shaders, such as ones that you could use for cell shading, along with different aspects of shaders, including things like parallax mapping, displacement, tessellation, that type of thing. And then I'm going to spend a very short amount of time, not too much time because it's only tangentially related, but I'm going to be spending a little bit of time talking about post effects, such as like outlines and other types of cell shading that are not, say, character shader based, but are more based on screen space effects. So let's sort of dive in, talk about the different types of shaders that you'll run into as a character artist, and talk about some different ways that you can use them in your character art, ways that you can achieve some fun effects, and I'm also going to be showing some very, very basic shader building inside of Unreal Engine 4. It's just kind of to give an example of the things that are available to you as a character artist, and available to game artists in general. But I'm going to be talking mostly about how you can integrate custom shaders into your character work so that you can achieve some, fun or interesting effects depending upon the type of character rendering you want to do. So here's a scene. Here's a character that I did a while ago, just for personal work. It was something. It was part of a small competition on Facebook, and yeah, I just wanted to make something that was based on a classic character that was from a 3D game, but from the early days of 3D when you didn't have many polygons to play with and everything was very pixelated and chunky. I wanted to do something that was a stylized, more updated version of something that people were familiar with. So this is Vivi Ornitier. I'm not sure of the exact pronunciation of his last name, but we'll just say Vivi. And on this character, you can see, on this character and his little pedestal and such, you can see a variety of different types of shaders. There are very basic shaders, such as the one you can see on his clothing. It just has some gloss and specular. There's a little bit of metal. But there are other types of shaders that I'm using that can drastically affect the final result of what you see on a model. Let's take a step back and talk about what shaders are, though. Because depending upon the systems that you're working with, the engine that you're working with, the types of character rendering that you want to do, a shader might mean several different types of things. So let's talk about, just from a very basic standpoint, what a shader really is, and then let's talk about the different types of shaders that we have in this scene. So let's hide these, and let's take a look at his hat and his clothing. So let me just hide everything aside from his hat. We can hide this little guy right here, and we can hide these things. Okay, so this is all one chunk of a model. On this model, on this chunk of the model, you can see. Oops, let's hide that as well because we don't need that. Here we go. So on this model, you can see that he has several different materials, all of which are actually on the same textures. Now, going back, I talked a little bit about having different materials using the same textures, but I didn't really talk too much about the way that the shader actually works to show those. Now, I did talk a bit about things like, normal maps, gloss maps, albedo, blah, 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 blah. But how did these things, when plugged into this shader, actually affect the shading? Well, certainly we've seen that normal maps can affect how lights behave in reference to the surface of the object. We've talked about albedo maps and how they tint things. We've talked about gloss maps and how they affect how shiny things look. But let's step back even farther and say, okay, what is this shader that's being used? I know sort of what a shader is. It's a thing that applies shading to something, but how does it apply shading? Well, I'm glad you asked. In the scene here, we have some pretty basic lights, along with the environment. Let's just turn everything except the key light off. So, oops, so that we can take a look at this. Okay, so here we have our key light. It's the only light in the scene that's affecting things. Now, when this key light, oops, let me turn off the camera constraints so this is a little easier. There we go. And let's go back to the key light, make sure that that's turned on. So when this key light shoots, well, light rays out of it in the direction of this little arrow, what it's doing is it's actually, the computer is doing a very small equation to see which faces are going towards that light and which faces are going away. Now, the more a face is pointed towards that light, as you can see here, the brighter it is. Now, it's not doing this by actually shooting out rays of light. It's doing this by saying, okay, what direction is the light coming from, and what is the value returned when I plug that vector, that number, that three coordinate angle into a small equation determining which way each of these little faces is pointing. Now, if the line coming from here is directly dead on for one of these faces, it's going to return the highest value possible given whatever the brightness of the light is, and therefore that's going to be a bright spot. And as you trend farther away according to the vertex normal, it's going to say, okay, this face is pointing in a direction other than the light direction, so it's going to get darker. So basically, it applies a gradient from white to black according to whichever direction this arrow is pointing. And you can see that as I change the direction of the light, it changes the direction that that white to black gradient is going and is oriented on this character. It's a very basic shader that says, do this little bit of math, find the product of the normal and the light vector, and find out what's different, and then, just apply some shading in that way. So that's a very rough approximation of how this works. I know it's from an artist standpoint, it's in dumb artist language, but that's basically how it works. I'm sure that there are actual shader artists out there who are probably screaming and yelling and being like, that's not 100% perfectly accurate. But for the artist, that's more or less all you need to know, is that it is doing that little bit of math to apply a gradient from black to white on your character. Now, the interesting thing about it applying that black to white gradient on the character is that it applies it as part of a pass, or a layer in the image. Let me show you what I mean by a pass. Let's open Photoshop, pull this up in here, and let's just make a new blank image, fill it with some sort of color, and say, okay, this is my albedo color for my shader. I want to apply some lighting to it. Well, the lighting in the engine is handled on a different layer than the color of the albedo color. So what it's going to do is it's going to make that black to white gradient somehow, and it's going to apply it on a separate layer, and the final result will look something like this. So there are lots of ways to get that black to white gradient. There's lots of math that you can use, and there's also a lot of different ways that you can blend gradients and various shades of light and dark onto this base color. So we can look at some of those right now. For example, I can paint some black here and some white here, and that could be all that I need to light my character. That would actually lead to, if I was wrapping that around my character in the same way that this light is wrapping around it, it could lead to some interesting and stylized results. However, you can do all these same mathematical operations that you get in the blending modes dialog here or the blending modes menu here in Photoshop. You can do those all in, say, a shader, and each one of these different blending modes corresponds to a different mathematical result between this top layer and this bottom layer. So often what you'll find is that, for example, the lighting is done with perhaps lighten mode or add mode. Lighten mode is a simple little equation that says, okay, if the pixels in this top layer are lighter than the pixels in this bottom layer, just fade those in. And if correspondingly for the darken mode, if the pixels in this layer are darker than here, fade them in. But anything that's not darker simply won't show up. You'll just get the original pixels, which is why when you're in darken mode, the white stuff doesn't show up, and if you're in lighten mode, the dark stuff doesn't show up. Things like overlay are a combination of those. They say if it's lighter than the base, then lighten it. If it's darker than the base, darken it. But if it's somewhere in between, well, do whatever comes out to sort of an even level. Once again, that's sort of simplifying things. We're character artists. We're not math gurus in general, so you don't really need to worry about the exact math behind it. But having a basic understanding of a lot of these things does help. So, back to here. Now that we have our, let's just turn that off, and we'll just we'll just say okay. So we'll say that this is completely flat shaded with no specular information. Now, if you want to apply specular information to this, you do something very similar to the calculation for determining how you light up your diffuse slash albedo, except the math for that, instead of it taking into account the albedo color, it's just going to take into account the specular color. Now in this case, I have a metalness map, and what that's going to do, I've already explained metalness so far, but what it's going to do is, we've seen before that it darkens the albedo and lightens the specular. However, specular is usually done in add mode, because what add mode does is it takes whatever the base is and literally adds a specular highlight on top. You can actually see that with this guy. Remember when I talked about the way I did his eyes, I have a shell around the outside of the eyes that is set to add transparency. If I set that to something like dither, what you're going to see is something very different than what you see right now. It's going to be this sort of like washed out whitish color, depending upon the alpha that I have. But all I want is the specular highlights, so I set it to add. And that makes it look like it's shiny. That's more or less how a lot of shaders apply specular to whatever surface you have. All right. So that's a basic rundown of how a shader can work. But let's take a look at what a shader is in context, in the context of a shader that you're going to build. And then let's take a look at, with the very basic general information that we get from looking at how a shader is built, let's take a look once again at some specialized shaders like skin shaders and cloth shaders and that type of thing. So let's switch over to Unreal 4 and take a look at a very basic shader. So let me just unplug these things. And, oops. Well, if I can. One moment. Okay. So in Unreal 4, it comes with a shader that is essentially a metalness shader. There are lots of different types of shaders you can use. So if we do, say, default lit, what that's going to do in the shader system is it's going to say, okay, I want it to have specular highlights. I want it to have a metallic, metalness input. I want it to have an option for roughness or gloss. And I want it to have an option for emissive color. Now, emissive color is pretty much what it sounds like. It's glowy stuff. It emits light. Normal is exactly what you would expect. It's the, you input a normal map. Ambient occlusion, once again, it's that grayscale map that, shows how much light is being occluded. So let's take a look at a very basic shader in context to show what we're going to get if we plug certain things in. And then we'll switch back to talking about different types of shaders. So if we want to get a base color to apply to our shader, what this is going to do is, let's just apply a flat color. I'll just make a solid color. We'll do some nice pinkish color. Press OK, and then just plug that into the base color. Now it's going to take a second for it to chug along and figure out what it's doing, but then it's going to apply it in here, and we're going to see the super basic shader that is built in to Unreal 4, and it's going to change the base color of these little checkers. And actually, let's make sure that we have a metallic value and a roughness value just so that it knows what it's going to do. We'll just save that. And it might take a second to load. Oh no. Oops, looks like there's been some technical issues. Uh-oh. Oh, this is not good. Looks like there are some technical issues. I'm going to stop the stream and we'll get right back to it.